Okay, easy to understand the calculus. Part 2. In the part 1, we explained the meaning of derivative function or differentiation. Differentiation is just to calculate the ratio of two infinitesimally small number, like 4 plus minus 4 and 2 plus minus 2. So 4 can be the result of a function. Say if we have a y equal x2 and we give a x infinitesimal number 2 plus, then f2 plus minus f2. So infinitesimally small number is 2 plus is 2 plus e epsilon. This epsilon can go to 0. Now when we take a limit, we just make epsilon 0. We calculate this function x squared, so 2 plus epsilon squared minus 4. The bottom here is epsilon only, so the result is 4 plus epsilon. Epsilon can go 0. Same way we do at the general function fx plus so and so. Okay, so result is 2x. Now derivative function is 2x. This is the result of y equal x squared. Now because it's the ratio of x increment over y increment, so physically we can interpret this as a slope. So the derivative function is actually the slope function. F prime x equal to x, that shows the slope at the point x. Okay, now we derive the integral function. Find integral function of y equal fx. Suppose you have a fx function, general form like that. Okay, now Sx is the area within this area. Okay, now we consider how much it's increased by infinitesimally small increment of x, which is e. So we take this derivatives function form. What's happening is it's going to be fx epsilon is this area divided by epsilon is going to give a height fx. So what's happening is the function of the area Sx, you take a derivative function of that, it's going to be fx. That means the integral function Sx is basically area function, which is opposite of integral. Sx, you differentiate it, you get fx. Okay, this is one way to get the integral. Now we promise that we're going to add the infinite number of infinitesimally number to get the integral. This technique is nothing to do with the derivative. It has its own method and meaning. Suppose you have a quarter of a circle. We divide into n sections. The 1/4 circle into n angles. Each angle is pi over 2n. Triangle area is, we calculate this triangle, this area. One of this divided area is this height, which is r sine theta, and this is r, so triangle is 1 over 2 r square sine. The total area is ns. We have n of them, so this is the total area. Now we take a theta 0, means angle becomes 0 by increasing number n. Then this term will be 1. So this is the area. So 1/4 of pi r square. Okay, so this is one of integral technique. It's nothing to do with derivative. Okay, but second example, we kind of associate the derivative and integral. This is true most of the time, but integral concept itself is independent from derivative. Okay, so let's review. Differentiation is to find the ratio of infinitesimally small numbers. Integral is to add the infinitesimally small numbers infinite times. That's what we show here. And derivative function of the integral function is itself. Okay, so we have explained what the derivative is and what the integral is. I hope you got the complete understanding of calculus this way.